Next we move further to the command translate. So translate is generally used to translate any entity or a surface from one place to another. Like there is a surface here, if I just want to translate this one, so one method is like direction and distance. So in this direction and distance method, I have to select any direction. I can select any line or any plane as a direction. So I am selecting a plane, this one, and after selection of the plane, the part is moved by the 200 mm normal to this. If I want it to be the another side, I have to put a minus sign here. You can hide and show the initial element from here as well. Also we have another options here. We can go to the point to point or the coordinates method. So let's go with the point to point method this time. I have selected the surface once again, and this time point to point method. So I have selected the start point and the end point. So by giving these two things, by giving these two values, start and end point, it is providing me the actually the direction and the value both is given to the translating command, so that the surface is now translated with these values. In the next option, I will translate this with the coordinate method, in which we have to select the XYZ values. Let's suppose 25, then 65, and then -90. And right now the axis system is selected as a default, which is an absolute axis system. So you can see like it is right now in the -90, so that's why it's below Z. Like I can change the value of 65, let's suppose to 200. If I do so, you can see it's translated differently. Next command, we will see the rotate command. To make the rotate, we have to select the first an element and a axis, and now I can rotate it with any angle about that axis. I can also select the values, let's suppose 20 degree, and after that I can select a repeat object after OK. If I click OK, it will ask me for how many instances I want, and if I click OK, I will have more 5 rotations. Similarly, this is also available in the translate command as well. Next command, we will see the symmetric command. Symmetric command is generally making a element symmetric about any plane or any other reference. So I am selecting a plane over here. So right now I got one more surface here which is exactly symmetry to this. So that is just generally the symmetry command. Now the next option we have scaling. So scaling is generally scaling a existing element with a particular reference. So I have selected this surface, and for the reference I can select a 0, 0 or a origin or a plane as well. So as I've selected the plane, if I increase the value, let's suppose 1.5, means 1.5 times of the initial one. But as I have selected the plane, you can see it is just increasing the surface value normal to surface. Now I am hiding this one and taking the scaling once again, and this time I will select the origin. And when I select a origin or a point, and at respect with the origin and the point, the scaling is going over. You can see this length is also increased compared to this one, so 2.5 times is increased. So similarly everything is scaled up by 2.5 times. While when I have selected the plane as a reference, not uniform scaling we have seen. So it basically depends on your ratio and the reference. Now the next command we will see the Affinity command. So in scaling we have an option to scale up with a fixed value like 1, 2, 3, 1.5, 1.3, and in every direction it is the same. But in Affinity I can give different values in different directions. So like I have selecting a element as extrude, origin as a point, then XY plane I can select this one is my XY plane, and then X-axis is generally normal to this plane, or by default it's have taken some values here even. Now I can just increase the value in X direction. You can see, so X direction become the twice, thrice, while the Y is still the same. So Y direction is actually here, X is actually here, so X is this direction, Y is this one, and Z is above. Let's suppose I'm changing the value for the Z now, so only the Z is going to change, no Y is the same at all. Let's suppose change the Y. Okay, so if I want the same result like the scaling have earlier, so what I can do, I can put same values in everywhere, and if I press OK, so this particular affinity and this scaling both have the same shape, exactly superimposing to each other. So this is all about the Affinity. So Affinity is basically giving that variable ratios, means different ratios to different directions, so that you can plan your scaling accordingly as per your need, while the scaling is the only a single value which is followed by or followed in all three directions. We are going to see our next command, which is axis to axis. So axis to axis translations means I have an element and I have a reference axis system. Okay, so I should have a reference axis system. Like here I have this green axis system where X is in this direction, Y is in this direction, and Z is in this direction, and this blue axis is my target axis. If you can see here, X direction is this one, Z direction is this one, and Y direction is this one. So if I predict my result, so in context of X is this one, and Z is my height basically, and Y is the kind of this area. So I will get the exact shape as per the reference to the target when I am doing this. Let's check it. Now selecting the reference, then selecting the target, or you can see now the Z is the same one like here as the above. The Y is like here, it's this much distance, and Y again here is the in this direction itself, and X is like moving inside and out. So here as well X is the same thing. I can press OK. So this is our axis to axis translating system or transformations. So let's start with the extrapolate command. So extrapolate command is generally for extrapolating or extending the surfaces or the curves. So it is valid for both surfaces and curves. Like the boundary or a free edge we have to select, we can't select a shared edge inside edge. Okay, so we have to select a free edge, that's why it is written as a boundary here. And then extrapolated means what kind of support you can provide. So I have selected this edge, it is automatically selected this surface as extrapolated and extrapolating it as a length of 30 mm. Now you can see there is an edge visible here. So this shows that this and this surface are under the tangency. Or I can show from here as well the continuity when I am creating the surface is the tangent continuity. And also the extremities are under the tangent. As the assemble results is selected, so we are getting a new surface assembled with the, or I can say join with the original one. If I uncheck the assemble result, if press OK, I will have a original surface separate and I will extended surface separate. If I just click over the assemble result, I will have a extrapolated surface assembled with the original one. Now I can change the tangent to the curvature continuity, and you can see there is no line visible here because the complete surface is a single surface with the curvature continuity. Here we also have the option, we can select up to an element and we can select a plane or some boundary conditions up to which I want to create the plane. Like I have a plane here and I will select this as a up to element, and if I click on the preview, I can see that only half the edges is going extrapolate because the plane is passing through the somewhere in the middle of the command or the edge which I have selected. So only that much will be extended. Now instead of doing this, I go up to the length option and now I have a propagation mode. I can select a tangent continuity. When I am selecting a tangent continuity, it identifies the edges which are tangent to the selected edge, and the rest of the edges is also selected under that, and the surface is extrapolated as propagation mode tangent continuity. We also have the option of point continuity. So in case of the point continuity, all the free boundary or the complete free boundary is selected and our extrapolated surface is continuously extrapolated over all around. So this is about the continuity on the propagation mode. So like the way we have done the extrapolation on the surfaces, we are now going to see extrapolation on the curves. So I can select a particular curve vertex as a point, and that line or the vertex is automatically selected. I can give the values like 23 here I have given, and I can extend the another end as well. I can also check the extrapolate both the sides identically. Also, I can change the continuity from tangent to curvature as well. Or I can give a different value to the second limit as well. There is one more option which I can do, is the support. I can support or give a surface over here so that the extrapolated curve will be on the surface itself. So like for this one, if I am going to select the surface, this, you can see my extrapolated surface is now projected over the given surface. If I uncheck or clear the selection over here, you can see now it is not over the surface, it is going out. But when I will check the support as the surface, you can see it is projected over the surface. Like the same, I can select this vertex to extrapolate tangentially. I will make the second limit as a 0 and press OK. I can also try to change the continuity here from tangent to the curvature. You can see easily that right now the following the curvature continuity makes this curve to move a little inward, because this is a circle which is projected over the surface. So it's trying to follow its circular continuity or the circle equation. Now again, if I just make to a tangent, it will be a straight one. So kind of this you can do the things in the every surface have some orientation, and that orientation I can generally reverse by taking the command invert orientation. So like this surface, if I select this one, so its orientation is now changed. So before doing this, if I want to check orientation of this surface, I can simply do it with the join command as well. I can select the join and click on the preview. You will find that the arrow is showing in up direction. So currently its orientation is on the upper side. Now I cancel the command and select the invert orientation. After selecting this one, we will find that the orientation is changed now to downward, and I can press OK. So if I am going to check the orientation of this inverse and click on the preview, we will find that the orientation is changed to the downward now. Now let's go with the near far option. So whenever in a command we have a multiple elements, we have to select a single element. We can go with the near or far element or the abstract option. So here the parallel curve is created with a 2.5 mm of a constant distance, and you will find that the curve is half is here and rest is trimmed this one side. Because of this discontinuity or the not having a connection between these two entities, when I press OK, it will show a multiple result options and giving me options to go with the near far or with the abstract or keep the all elements. So in this case I will just go with the keep all element here, and you will find that parallel is now with the highlighting the two elements. Now I can go to the my option near far and select the parallel here and give a reference element. I have a point here which I can select as a reference element. I have selected this point, and you can easily see that the curve is highlighted in magenta color is selected as a near element to the reference element. If I check on the far, our second element will be the selected one or will be shown in the magenta color like the same. If I press OK, only the second one or the magenta highlighted curve will left, and I can use this further as per my need for the CAD modeling. So this is the near far for the multiple results.